Welcome class to our guided notes session for Skill 4 from Unit 3. And in this video, we're going to look at multiplying and dividing rational expressions. It will be very similar to simplifying. It's going to basically involve factoring, canceling, and multiplying. The multiplying part is really the only thing extra from simplifying. It's a lot of factoring and canceling. Dividing is basically going to just involve flipping first. Flipping, and then following the steps above. So you can think of the steps in this video as basically are going to be factor, cancel, and multiply. And for fractions, you just multiply straight across. And then when you divide two fractions, you basically multiply by the reciprocal. So we start by flipping the second one, right? Flip the second fraction. And then we factor, and then we cancel, and then we multiply. So the flipping and the multiplying are really the only things added to Skill 4 that were not in Skill 2. So just a quick review on what canceling actually is. Canceling is when we divide two identical quantities to equal 1. So we divide two identical quantities to equal 1. An example here would be x minus 3 divided by x minus 3. We say that those cancel. They divide to equal 1 and therefore cancel. Now you got to be careful when the order of subtraction switches. We noticed this in our practice problems the other day. If you have 3 minus x, that is not exactly the same as x minus 3. You would have to first factor out a negative 1. Factor a negative 1 from the numerator, and then that would turn this 3 into a negative 3, because factoring is the same as dividing, and positive 3 divided by negative 1 would equal negative 3, and then negative 1x divided by negative 1 would become positive x, right? And then that's all over x minus 3. But then you might notice, okay, negative 3 positive x, that's just the same thing as x minus 3. And so actually what's interesting here, it turns out that if you factor out a negative 1 from a binomial, it can actually reverse the order of subtraction, right? 3 minus x divided by or factored out by negative 1 is equal to x minus 3. It reverses the order of subtraction. So these quantities here are identical, right? The x minus 3 and the x minus 3. And so they divide out to equal positive 1, but then there's this remaining factor of negative 1. So when the order of subtraction is reversed, then those will divide to equal negative 1, not positive 1, because this is negative 1 times x minus 3. Now the order of addition, you might remember from the same practice assignment, doesn't matter, right? 3 plus x is equal to x plus 3, because order of addition doesn't change the value. Order of subtraction will change the sign. Order of addition won't change anything. So 3 plus x and x plus 3 are identical quantities and therefore will cancel out or divide out to equal 1. So these were great. These were great. That one we just had to be aware of the negative 1, right? Pull it out and then they cancel and then you're left with negative 1. Now here, these do not cancel. These do not simplify. It just equals itself because remember, x is not a factor of either the numerator or the denominator because it's not being multiplied to 3. It's being subtracted by 3 here and then added by 3. And then again, 3 is not a factor of either the numerator or denominator because it's not being multiplied to x. It's being subtracted from x and added to x. So therefore, this will not equal 1. It will also not equal negative 1. It just equals this. Only identical quantities can cancel out to equal 1, and then be wary of the order of subtraction. Those will cancel to equal negative 1. Okay, so let's start with number 1. We see that there's multiplication symbol right here. Okay, so I'm going to start by factoring, right? Step 1 is to factor. So I notice in the first numerator, there is a GCF of 4. So I'm going to pull a 4 out of 8 and 4, and that will leave me with 2x minus 1. And then in the denominator, I can pull a 3 out of 3 and 9, and that will leave me with x minus 3. So I factored the numerator and denominator of the first one. Going on to the second fraction now, I notice a GCF of 5. I can take that out, and then I'm left with x minus 3. And then I notice a GCF of 5 again in the denominator of that second fraction, leaving me with 2x minus 1. So something else that you can do when you're multiplying is this thing called cross canceling. This x minus 3 can cancel with that x minus 3, and that is because x minus 3 divided by x minus 3 divides to equal 1. I can also cross cancel the 2x minus 1s from the numerator to the denominator because those quantities are identical and they will divide to equal 1. And I can cancel 5 over 5 because that is an identical quantity that will divide out to equal 1. The reason you can cross cancel is because each of these things, the number 4, the quantity 2x minus 1, the number 5, the quantity x minus 3, they're all being connected through multiplication. It's one long string of multiplication, and same thing in the denominator. 3 is being multiplied to x minus 3, which is being multiplied to 5, which is being multiplied to 2x minus 1. Everything's a factor because everything is being multiplied to everything else. So that is why you can do a cross like this, because as long as you've got a common factor in the numerator, the whole numerator, something in common with a factor in the whole denominator, they can divide to equal 1. Okay? So then for my simplified answer, it's just whatever is remaining, right? Which is just a 4 from this first, from the numerator, and then a 3 from the denominator. So this entire multiplication problem, it just multiplied together and resulted in a simple fraction 4/3. This would be my simplest answer right here. But remember, dividing by 0 is not allowed. So I have to take these denominators, right? 3x minus 9 and 10x minus 5. And I have to make sure that I exclude whatever value of x would make them 0. So I set them equal to 0 and I solve to find what value of x is going to make 3x minus 9 equal to 0. And that is x equaling 3. So then I can't let x be 3, right? And then I do a similar thing with the other denominator. I set it equal to 0, again, to figure out what value of x would cause it to equal 0. And I get x cannot be 5 over 10, which if you simplify that is 1/2. So x cannot be 3, and it cannot be 1/2. But for every other x, if I multiply these expressions together, the result will be 4/3. Moving on to number 2. I can see that the factoring for this basically gets more complicated, right? That's how these things get more complicated, is just more difficult factoring, but the steps will remain the same. I'm going to factor, I'm going to cancel, and then I'm going to multiply straight across any remaining factors in the expression. So I'm going to start with the numerator of the first fraction. I notice it only has the 2 terms. So I just notice it has a GCF of x in both terms, so I can take that or factor that out. So I take an x out and I'm left with x plus 3. And then in the denominator, I notice it has that weird kind of reversed subtraction, right? So what I'm going to do is factor out a -1 so that I can reverse the order of subtraction. But just a quick reminder, if you divide +1 by -1, that changes the sign to -1. And then if you divide -1 by -1, that changes the sign to +1. So really factoring out a -1 just changes the signs. But then when you change the signs, you are reversing the subtraction, right? This is just +x minus 1. So I'm going to go ahead and write it that way because we're just more used to seeing the variable come first. So I took the -1 out and I have x minus 1. So the first fraction is done. And then for the second fraction, I'm going to have to do the trinomial factoring. So I'm going to do the first one over here. I have to multiply 2 and -5 to get -10. And then I'll put the 3 down here. And then I need to find 2 numbers that multiply to -10, but then at the same time add to 3. So I'm going to use +5 and -2. And then because the a value is 2, I'm going to have to do the grouping, right? So I'll have to do 2x squared plus 5x plus negative 2x minus 5. Remember, the 2x squared stays the same. The minus 5 stays the same. It's the 3x that splits into these two numbers. And then we group, group, group. And then we pull out an x from this first group. And then a negative 1, right? Taking out a negative 1 allows us to change the signs of everything. So then this will turn into also positive 2x plus 5, which is what I needed it to be, right? Because I need these binomials to be identical. And then I factor out that identical binomial, and I'm left with x minus 1. So those are the factors of the numerator, okay? Now I'm going to do a similar process for the denominator. I'm going to do 2 times 15, so that's 30. And then I'll put 11 down here. So I need two numbers that multiply to 30, and then at the same time add to 11, so that'll be 5 and 6. And then I rewrite the trinomial, right, 2x squared, and I split 11 into 5 and 6. I leave the 15 as 15, and then I group. And then I'll pull out an x from the first one to get 2x plus 5. And I can pull a 3 out from the second one to again get 2x plus 5, which is what I needed it to be. I need these binomials to be identical. And then I can factor out the identical binomial, and it leaves me with x plus 3. So those are the factors of the denominator of the second fraction. So now everything is factored and everything is being connected through multiplication, right? It's one long string of multiplication, which means any common factors between the numerator and denominator can be canceled out. So I see x minus 1s, right? Because x minus 1 divided by x minus 1 is 1. So those reduce out to leave 1. I see 2x plus 5s can cancel out because dividing an identical quantity by itself will leave behind just the factor of 1. And then x plus 3 divided by x plus 3 can also reduce to equal 1. So 3 identical quantities were being multiplied on the top and then divided on the bottom. So then that all just equaled positive 1. But I did have an x left in the numerator and a negative 1 left in the denominator. So that equals x divided by negative 1, and then that equals negative x as my final simplified answer. So all of that being multiplied together reduced down to just a very simple expression of negative x. However, I have to make sure that I don't ever divide by 0. And I was dividing by a lot of stuff here, right? I've got 3 factors, 1, 2, 3 that I was dividing by that could potentially equal 0. So I need to set each one of those factors equal to 0 to ensure that I don't let x be whatever numbers would make either of these factors 0. I don't need to worry about the factor of negative 1 because it's not 0, it's negative 1, and it will always be negative 1, so it's not a threat. These guys are the things that could change value depending on x, right? So I need to figure out what x makes this 0, what x makes that 0, what x makes that 0, and then not let x equal any of those things. So I just solve. So x can't be 1 for the first factor. And then it can't be negative 5/2 for the second factor. And then it can't be negative 3 for the third factor. So x cannot be 1, it cannot be negative 5/2, and it cannot be negative 3. These would be all of my restrictions. So for any other x, excluding these 3, this expression will will multiply together to equal negative x. Okay, so why don't you guys give number 3 a try? Yeah, go ahead and pause the video at this point, multiply it out, get your simplest answer, get your excluded values, and then check and see if they're right. Welcome back. So let's see how you did. With number 3, what we notice is that there's 4 factors of x in the numerator of that first fraction. You don't have to write them all out, but you do need to be aware that there are 4 full factors of x. In the denominator, there's actually a GCF of x. So there was also one single factor of x in the denominator, And when you factor it out, it leaves you with the difference of squares, x squared minus 25, which then factors further into x plus 5, x minus 5. And then on the second fraction, you can take out a 3 from the numerator, and it leaves you with 3, and then the quantity x plus 5. And then you can factor a 4 from the denominator, which leaves you with 4, and then the quantity x plus 2. And then what happened next is that the factors of x plus 5 canceled. One of the factors of x canceled. And then 2 could divide into 4, leaving a 2 behind on the denominator, right? There was a 1 left in the numerator and a 2 left in the denominator. So then you're supposed to multiply the rest of the stuff together. So that means there were 3 factors of x left and then the number 3. So the numerator had 3x cubed. And then in the denominator, I didn't really FOIL it out. I just wrote it as like one product. This factor of 2 times the factor of x minus 5 times the factor of x plus 2. This is the simplified version, or the result, what you would get if you multiplied these fractions together. And then now when you're deciding your excluded values, it also includes any time at any point in the problem where you divided by 0. So like this x was an issue, right? Can't let x be 0. And then when you factor x squared minus 25, you get x plus 5 and x minus 5. So then x can't be negative 5 or 5. And then over here with our factor of x plus 2, x can't be negative 2. So in example 4, we have division now, right? Example 4, we're moving to dividing. So the steps we're going to follow will first involve flipping, right? Flip the second fraction, put that in parentheses. We flip the second fraction, we factor, we cancel, and then we multiply together any remaining factors. So flip, factor, cancel, multiply. Okay, so then that means I'm going to start, the first fraction stays the same, but this division turns into multiplication, and then I flip it. So the 14x squared ends up in the numerator, and the 4x plus 2 ends up in the denominator. And then I basically start factoring. So the first numerator is just 8 and x, and then 21 is 21 times x times x times x. You don't have to do this. We just need to be aware, right? And then I've got 14 and x times x, and then I can take a 2 out of this binomial, and I'll be left with 2x plus 1. So maybe I should factor the numbers a little bit just to kind of see what we're dealing with. So the 8 can be broken into 2 and 4. The 21 could be broken up to 3 and 7. 14 could be broken into 2 and 7, and then we already factored the 2 times 2x plus 1. Just makes it a little easier to see what will cancel. So the 7s will cancel out, right? 7 divided by 7 is 1. These x's cancel out, and then actually these 2 will cancel those 2. So every single x eventually divided with something, right? Because x over x is 1. And so there were 3 of those, right? X over x, x over x, x over x. And then these 2's will cancel out, and I think that's it. So in the numerator, I'm left with 8. In the denominator, I'm left with 3 times 2x plus 1. And I just multiply those things straight across. So this is 8 in the numerator, divided by 3 times 2x plus 1 in the denominator. So that is my simplest answer. And then I just have to determine what values of x would be excluded at any point. So that includes right here, and right here. So basically x can't be 0, because if x were 0, then x squared would be 0, and so would x cubed. But also 4x plus 2 can't be 0, because when I flipped this fraction over, then that ended up in the denominator also. So I'll just solve that equation. So then it looks like if x were to equal negative 2 over 4, which is negative 1/2, then I'd have a problem. This would turn into 0, so then I just cannot let x be negative 1/2, and those are the excluded values. In number 5, same idea, right? I start by flipping the second fraction, so I'll keep the first one as is. I'll turn that division into multiplication, and then this denominator goes up in the numerator, and then vice versa. So the 3x squared plus 5x plus 2 goes in the denominator. Then I factor. These guys are already in simplest form. I'll just go ahead and put parentheses around them. They're done. These guys need to be factored. So the x squared plus 6x plus 8, I just need two numbers that multiply to 8 and add to 6, which are 2 and 4. So then the numerator of that fraction factors into x plus 2 times x plus 4. And then for the denominator, I'll do that over here. So for this guy, I look at the 3, I multiply it to the 2, and that gives me a 6. And then I have to find two numbers that multiply to 6 and add to 5. So I'm going to do 2 and 3. But since the a value on that is not 1, it's 3, I have to do the grouping process. So I just rewrite this whole trinomial, but I split 5x into 2x and 3x, and then I group. And I'll take an x out of the first group, which leaves me with 3x plus 2, and then there's no common factor with the second group, so I'll just say plus 1 times 3x plus 2, and then I have my common factor of 3x plus 2 times the remaining values of x plus 1. So those are the factors of my denominator. And after all of that work, all that work, the only things that cancel are the x plus 4. So that's kind of frustrating. That's like super irritating. But you know what? That's just the way it is sometimes. We do all the work to just see if maybe there's any common factors, and sometimes there's not very many. But at any rate, there was these, so those cancel. So then I have to just multiply straight across these two together with those two. And you don't need to FOIL, just write it as a product. So the simplified answer for this would be the factors of x plus 5 times x plus 2 in the numerator, divided by the factors of 3x plus 2 times x plus 1 in the denominator. So that's my simplest answer. That's what I get when I divide these fractions. And then again, when you're looking for your excluded values, it's anything that was in the denominator at any point. So here, here, and then also here. So that's a lot of factors. There's x plus 4 from this part, so I don't want to let that be 0. So then that means x can't be negative 4. Then when I factored x squared plus 6x plus 8, I got x plus 2 times x plus 4. So we already dealt with the x plus 4, but now I need to deal with the x plus 2. Right? So that would give me an excluded value of negative 2. X can't be that. So that takes care of these denominators. And then when I flip this fraction over, this guy ended up in the denominator. So maybe the factoring that I did wasn't a complete waste of time, because I need to figure out what values of x would make this denominator equal to 0. And so knowing that it consists of these two factors is helpful, because then I can just set them each equal to 0 and solve for x. So for one of them, I get that x cannot be negative 2/3. And then for the other one, I get that x cannot be negative 1. So lots of excluded values on this one, because there were so many factors it being in the denominator at some point. 1 here, 2 here, and then 2 more right there. Last but not least, we come to example 6. So example 6 looks really scary at first because it's one fraction on top of another one. But if we can just think of this division bar as just that, division. Maybe even we can rewrite it that way. Use this division symbol, which maybe is not as scary as the large fraction bar. Then we can see that it's just like examples 4 and 5. It's really no different. It's one fraction being divided by, this large fraction bar means divided by another fraction. So we flip, factor, cancel, multiply. Okay, I'll flip the second one. So then this turns into, so I turn that division into multiplication. Right, that becomes multiplication, and then this second fraction will flip, so the x squared plus 3x ends up in the numerator, and x squared minus 4x plus 4 in the denominator. Now this one is also easier to factor than the last one, so that's kind of nice. The numerator of the first fraction is a difference of squares, so that factors into x plus 2, x minus 2. And the numerator of the second fraction is just a GCF, so I'll just take out x, and I'm left with x plus 3. And the denominator of the second fraction is a perfect square. It's just going to be x minus 2 squared, but I'll show you the work for that one. I just need to find two numbers that multiply to positive 4 and then at the same time add to negative 4. And it just so happens that it's the same value added to itself, right? Negative 2 plus negative 2 is negative 4. Negative 2 times negative 2 is positive 4. So those are my factors. And then I just look for common factors. And I see I have x minus 2 is a common factor. And so is x plus 3. And they have to be common factors between the numerator and the denominator, which they are. And then I just multiply together any factors that remain. So my simplest answer would be x times x plus 2 divided by a single factor of x minus 2. And there's my simplified answer. What I get when I divide these two fractions. See, it seemed so scary, but ended up not being so hard. I just need to find all the excluded values. So I have to look at all denominators at all points in time. So then there's this one, and this one. So there was the factor of x plus 3 that I want to figure out what would make x, or what value of x would make it 0. And I see, okay, x cannot be negative 3. Then the factors of x squared plus 3x are right here. Well, we already dealt with x plus 3, but then I see there's an x, right? So if x is 0, then that's a problem. So x can't be 0. And then this guy right here ended up in the denominator, x squared minus 4x plus 4. But that has two of the same factor, so I just need to set one of them equal to 0. And I see, okay, x can't be 2. So as long as x is not any of these three values, these fractions will divide to equal x times x plus 2 over x minus 2. And that concludes our lesson on this, and I will see you tomorrow for some practice.